Today we are going to study logarithmic differentiation. Let's understand it. Suppose we are given y equal to fx, which is equal to, suppose, u function of x power v function of x. So I will write like ux and vx. Now we can take log y equal to, we know that log m power n is equal to n log m. So it will become bx log ux. We assume it as product of two functions and we differentiate. Differentiation of log y is 1 upon y d by y dx. And if we apply product rule here, vx into d upon dx of log ux, that would be 1 upon ux times derivative of ux. So that is, let's write it as u dash x. Remember, I told you the rule, d upon dx of log block becomes 1 upon block times d upon dx of block. Same rule. Plus log ux into d upon dx of vx. Let's write it as v dash x. Now dy by dx equal to y times this thing, but y is question itself. So we write it here, ux power vx times vx upon ux times u dash x plus log ux times v dash x. So this is our answer. Now let's take some examples to understand it clearly. So question number 1. Suppose we are given y equal to x minus 3 times x squared plus 4 divided by 3x squared plus 4x plus 5 whole power half or square root. So we take log. So log y equal to 1 by 2 will come in the beginning, then log x minus 3 plus log x squared plus 4 minus log 3x squared plus 4x plus 5. Rule that is being applied is log m into n divided by l becomes log m plus log n minus log l. Now we differentiate each term. 1 upon y d by y dx 1 by 2. This will become rule of d upon dx log block, that is 1 upon x minus 3 into derivative of x minus 3, that is 1, plus 1 upon x squared plus 4, and then derivative of this will give 2x minus 1 upon 3x squared plus 4x plus 5 into d upon dx of 3x squared plus 4x plus 5. So that will give 6x plus 4. Although you have to write separate step, here you will write 1 upon x minus 3 into d upon dx x minus 3 plus 1 upon x squared plus 4 into d upon dx of x squared plus 4 minus 1 upon 3x squared plus 4x plus 5 into d upon dx of 3x square plus 4x plus 5, and the next step will be this. Okay, now dy by dx equal to y times this, but y is question itself. So we copy the question. So first we write 1 by 2, then we write x minus 3 times x squared plus 4 divided by 3x squared plus 4x plus 5 whole power half times this thing 1 upon x minus 3 plus 2x upon x squared plus 4 minus 6x plus 4 divided by 3x squared plus 4x plus 5, which is our answer. Now, let's take next question, question number 2. Suppose we are given y equal to a power x. So taking log both sides, so it will become log y equal to x log a. Log a is a constant. Here base is e. Now its differentiation will be 0, so we will not apply product rule here. We will assume it constant and we will set x only. So 1 upon y dy by dx is equal to log a base e, and differentiation of x is 1. So dy by dx is equal to y times log a, and we put the value of y, so it will become a power x log a. Let's see next question. Suppose we are given y equal to x power sine x. We take log, so log y equal to sine x log x. This is first function, this is second function. So we can apply product rule. So 1 upon y dy by dx, which is equal to sine x into differentiation of log x, that is 1 upon x, plus log x into differentiation of sine x is cos x. We can take LCM x sine x plus x cos x times log x. So dy by dx will be y times. So here y equal to x power sine x. So we can write x power sine x times sine x plus x cos x log x whole by x, which is our answer. Now let's take next question. Next question is, we are given y power x plus x power y plus x power x equal to a power b, and we have to find out dy by dx. So let's write it as u plus v plus w equal to a power b, and we differentiate it. So du upon dx plus dv upon dx plus dw upon dx equal to 0, because this is constant. Now we assume it as equation number 1, and we differentiate these terms separately. So here u equal to y power x, we take log. So log u equal to x log y. We differentiate it with respect to x. So 1 upon u du upon dx equal to x into 1 upon y dy by dx plus log y into 1. So du upon dx equal to u times this much, but u is y power x. So x upon y dy by dx plus log y. Suppose this is equation number 2. Now we consider v. So v is x power y. V equal to x power y. We take log. So log v equal to y log x. We differentiated 1 upon v dv upon dx equal to y into differentiation of log x, that is 1 upon x, plus log x into differentiation of y, that is dy by dx. So dv upon dx we can get, so dv upon dx will be x power y upon x plus log x into dy by dx. Suppose this is equation number 3. Now w equal to x power x. We take log, so log w equal to x log x. We differentiate it. So 1 upon w dw by dx gives x into derivative of log x, that is 1 upon x plus log x into derivative of x, that is 1. So 1 plus log x, or dw upon dx equal to w times this much, but w is question, x power x times 1 plus log x. This is equation number 4. Now, putting these values in equation number 1, du upon dx plus dv upon dx plus dw upon dx equal to 0. So let's put these values. So du upon dx plus dv upon dx plus dw upon dx equal to 0. So du upon dx is y power x log y plus y power x minus 1 times x dy by dx. Here, from here, if we open the bracket, y power x into x divided by y. So y power x divided by y will give y power x minus 1. So don't get confused. So y power x minus 1 times x dy by dx plus, we put value of dv upon dx. So similarly, it will become x power y minus 1 times y plus x power y times log x dy by dx plus value of dw upon dx, x power x times 1 plus log x equal to 0. Now we take a dy by dx common from here. So next step will be dy by dx common. Then x y power x minus 1 plus x power y log x equal to other terms that don't contain dy by dx, like this, and this can be shifted to RHS. So it will become y power x log y plus y x power y minus 1 plus x power x 1 plus log x. Now we can divide this term by this term. So we get dy by dx equals minus y power x log y plus y x power y minus 1 plus x power x 1 plus log x whole divided by x y x minus 1 plus x power y log x, which is the answer. Now let's consider next question. We are given y power x equal to x power y, and we have to find out dy by dx. We take log x log y equal to y log x. We differentiated x into 1 upon y dy by dx plus log y into 1 differentiation of x equal to y into differentiation of log x, that is 1 upon x plus log x into differentiation of y, that is dy by dx. We write dy by dx containing terms together, dy by dx, then x upon y, where this term is shifted to LHS, we change its sign, so it will become log x equal to y upon x, and this term can be taken to RHS log y. So dy by dx times x minus y log x divided by y equal to y minus x log y divided by x, or dy by dx equals y minus x log y divided by y, divided by x times y divided by x minus y log x. So this is our answer. Now let's see one more question. So question number 6. We are given xy equal to e to the power x minus y. If we take log, so before that, let's see one property. Log e a power x. So sorry, log e power x becomes x. Log e power block will become block. So here, if we take log xy equal to log e power x minus y. So here, property of log m into n becomes log m plus log n. So this will become log x plus log y, and this will become only x minus y, because as I told you, base and this number both are same, then this thing will be removed and only the power will be left. So here it will become x minus y. Now we differentiate 1 upon x plus 1 upon y dy by dx equal to this will be 1 minus dy by dx. Now we write dy by dx terms together. 1 up here we can write dy by dx times 1 upon y plus, from here it is 1 equal to 1 minus 1 upon x. So dy by dx, it will become 1 plus y upon y equal to, this will become x minus 1 upon x, from where we get dy by dx equal to x minus 1 upon x times y upon 1 plus y, which is our answer. Thank you for watching.